I want to buy another case. All right. Oh.
Can we do something other than? Can we do something other than 2?
What's that?
It's not the hardest thing. It's gonna be like this.
Can we do something other than 2?
I would say hyperbolas are a little bit more difficult than ellipses.
So I mean, ellipsis.
But that doesn't divide.
You made me write hyperbola already.
Kind of glad we're doing this one.
Oh no!
Yeah, how was that now?
What we got it. All right. Good. So the first step, get a 1 there. Now, how I need to write this as x squared over something so I can see what a squared is. If this is 2/25, if I want to force it down, it's going to become. Let me say all that again.
112.5.
No, come on. It's going to become 25 halves.
Oh yeah.
I'm going to divide by a fraction and multiply by its reciprocal, so I'm just kind of undoing it. So I've got to have in the form x squared over a squared. Can't have any. This has to be a 1 here. So if I have fractions going on, I got to force it down below. Plus, here I'm going to get y squared over 5, so that's fine. Equals 1. All right, so a squared is 25 over 2. So a is 5 over 2. Yeah, 5 root 2 over 2, which is roughly 3.
No.
Yeah. No, it's roughly 3.5, 3.5.
Yeah, 353. Because it knows what root 0 is and root 3.
Yeah, make that bad boy a decimal, because we got to graph these things. I do not think in terms of root 2, so make it into a decimal. You only have to go out one place because we're going to do this by hand. 3.5 is going to be the same damn place as 3.53, so make it 1 decimal. So here b squared is 5, so b is root 5, which is roughly
2.2.
2.2. So which axis is going to be longer on, x or y? X, because it's a bigger number on the x squared, right? Don't make this more than it is. Ellipses should be kind of not so hard because they're 1 step away from a circle. How do I find my? Yeah.
On A, when you move the square over to make the square root, how come it's 2 and not 1 square?
Well, I make it 5 over root 2 and then I just rationalized it. I really didn't have to because we're going to make it a decimal anyway, but I sort of think this way automatically. Okay. So what's my focus? Focus, focal length. You like that one better?
Square root of 1.2.
Yeah, so it'll be 3. We got to be careful now. We got to subtract the squares.
Yeah.
Right?
Square root of 15.
So it'll be 5 minus 25 over 2. Or the other way around, Jeff, you could do it.
Yeah.
25 over 2 minus 5, which would be square root of 15 halves, which is roughly, it's like 2.7.
Yeah.
2.7.
Dude,
2.7, yeah. Wow.
You and your math.
I'm a math teacher, man. What the hell? So, all right. So let's put all this together. I mean, this is the ugliest you can see it because it's got a lot of decimals. It's got all these radicals running around. But we just make them all into decimal so I can graph them. You already know it's going to look something like this for a really quick sketch because it's longer in the x direction. So now you just got to be a little more precise about it. Got to go up and down by 3.5. Go down here by just a little over 2. So 3.5 up, 3.5 down, 2.2 up, 2.2 down. I mean, that's, that's like, please give me more of those.
I like them.
And then you connect it, you make your 4 perfectly deformed whatever the hell. It was good for a while. It's a thing of beauty, or it's at least a thing. And then my foci, if I wanted to, don't put a point there because there's not a point on the graph. What I normally do if I had to put them on there, is put a little circle there. There's my 2.7. Or you just put a little X, the F1 is one of those, or C, it doesn't matter. So those are my foci. Foci, however you like it. Foci sounds some weird god.
Do we have to put the F?
Loki and his brother Foci.
What would mean locus?
Locus?
On the or on that homework, it was
Locus
asking
of
for
control.
what was that ellipsis that it was asking
I
for?
don't know, but everything when
The ellipsical
US
distance
ends with the I.
that it was asking for? Do
No.
you remember that word?
It's like focaccia.
On the test, are you gonna ask for the eccentricities? Yeah.
I'm not overly concerned with that, but let me see if I remember correctly. Isn't that C over A?
He
Yes.
doesn't like it anymore. When is it?
I don't really.
Or
what's that for? Though?
I'm not too concerned about it. Eccentricity just has to deal with how far away from a circle it is.
Okay.
So the more compressed it gets, it's further away from the circle.
So it's like the slope idea. Of
You
for a
can
circle.
think of it like that, sort of.
The difference is. No.
Because if you construct a hyperbola, we'll do it in a minute, and I'll show you how you can consider like the imaginary ellipse in the middle of it. So the hyperbolas involve those asymptotes, which have slopes to them. So that's why you can consider it as you smush them down. Then you get more and more eccentric because you're anyway.
Okay, what does that weird E, C over A is?
All right.
Okay. Never mind that, okay.
So hyperbolas.
Are we gonna go through the term or should I?
The only difference between ellipses and hyperbolas, equation-wise, is hyperbolas have a minus. So start off with one that's not too ugly.
Okay, so can we write this hyperbola now?
Yeah, let's make it hyperbola. Hyperbola.
Hyperbola.
So it's going to feel a little bit similar, except now c squared is going to be a squared plus b squared, which is one reason why it's even less of a reason to change a and b at all. You have two options for hyperbola. It could either look like this, or it could look like this. So it could either sit on the y-axis and have no x-intercepts, or it could sit on the x-axis and have no y-intercepts. From the equation, if I made x 0, could that ever have any answers on a real plane? No. I can't have negative y squared equaling a positive 1. You with me?
Yeah.
So obviously, it can't have any of these intercepts, whatever this variable is. Say that again. So if we make x 0, I'm trying to find the y-intercepts. We just figured out there are no y-intercepts because there's no way that could ever work. So if there are no y-intercepts, what situation am I in? Down here. So it sits on the x-axis. Whoever's first is the axis it sits on. Very simple to remember, right? X squared is first. It sits on the x-axis. They could be very evil and do this, in which case you'd first have to divide by -1, which would flip everything around. But as long as it equals +1, whoever's first, that's the axis it sits on. Cool. So far, so good?
So are you gonna do evilness?
No. Not enough time for me though. Oh, that was nice. So here a squared is 4, so a is 2. B squared is 36, so b is 6. So c is square root of 40, which is roughly, let's not even simplify it, just 6 point something or other. 6.3? Okay. So you've already determined that this thing opens on the x-axis. So my foci would be at plus or minus 6.30. Yeah, I went a little quick there, but it's very similar to the ellipse work. this is where things are different now with hyperbolas. I can't remember this book, to be completely honest. I didn't really look at the book too much for this, but I can't remember now if it does. Yes, it does. Cool. So it does the box method also, which I think is a really good idea. And then you can put in the asymptotes. Okay. So let's see, where can we start? So if you go by the book method, which is what I put up on here, where do you go? The figure out the asymptotes. It's either B over A or A over B. And I can't remember now this book, what's it do? It always puts A first. Okay. I love it. But basically, what should make sense, it's the slope. And what's slope? It's y over x, right? So if you think about it, if I do, let me make sure you guys are with me. So if you have this piece of paper, or if you have the section in 11.3, I want to point something out. Page 742 at the bottom. They always make this plus or minus the number under the y over the number under the x. And why does that make sense? Because slope is change in y over change in x. So nothing amazing there, really. So here this would be 6 because it's under the y, over 2 because it's under the x. So plus or minus 3. Cool. How are we doing so far? Now the first step of hyperbola is going to feel a lot like an ellipse. I do want to walk out this far and this far on this axis and this axis. It's kind of nice. Whatever the number's width is the where I go. You can't beat that for a simple way to do things. So on the y-axis I want to go up and down 6. On the x I want to go left and right 2. So here and here, these are going to be my actual points. And these are not points on my graph. So hyperbola in this case is going to be okay. But we need a little more detail here. I don't just want you to throw in, don't do this as a final answer. That's not good. So the way I can do this is, one nice thing, I can immediately make this little rectangle here. Which, believe it or not, is a really nice track, because now I want my asymptotes to run right through the corners. And if you double check, it's supposed to be plus or minus 3x, and sure enough, up 3 over 1, up 3 over 1, and there you go. So that's exactly matching up with this. Okay, now it's. So in reality, I don't even need this equation. I could always draw that little rectangle and just go through the corners. This is just sort of a verification. So my asymptotes will be there and there. So if I would have turned these around, it would have opened like this. But since, of course, it's this way, it's going to open like that. So a lot of things that, like electrons or comets or things, they have these hyperbolic approach. They come close to something and then they skip off and they go away. So hyperbolic graphs have their uses also in astronomy and chemistry, believe it or not. Okay, so hyperbolas, when you first look at them, they look like they're going to be completely freaky as hell. And it turns out to not really be that bad. It's a lot like an ellipse at the beginning. The only difference is, now look here, this is what I was talking about earlier. Here's my little imaginary ellipse that kind of lives inside, right? So if I put a plus there, that blue dotted line would have been my answer, right? Okay, nifty, nifty.
Okay, so what does coordinates and foci mean?
Oh, so the foci, what was it? 6.3. So now it's, let's see, where am I at? So the focus here would be 1, 2, 3, 4. Focus is way out here, 6.3 and negative 6.3. 1, 2, 3, 6.3. So I need to put a little, let's just put a little X there for focus.
What do you see for?
So the neat thing is, as I don't know if they say this in the book, I don't know if they make this into a point, but the closer I push those, if I push them, no, so it makes this thing go, eh. So if I push the focus closer, it's going to make that go like that. It's kind of neat. So that sounds like a really good idea for a Java applet. Push that focus closer, and it makes that cave in. Pull it out farther, makes it cave out.
But there's no length. Can see.
So again, the definition of hyperbola, if you go back to it, it's sort of the opposite of the ellipse. It's the set of all points in a plane where the differences of the distances between two fixed points is a constant. So the difference between, so this point here, the difference between this length and that length is the same as here. The difference between those two lengths is the same. It's a constant. And it makes sense because there's a minus in my equation, right? So a hyperbola is where the difference in those two lengths, those distances from the foci, is the set of all points where the distances are the same. So I can start by putting foci in somewhere, and then that constructs a hyperbola. I'm not saying it would be easy to do it that way, but that's really how it's kind of built. Okay. Let me see if they have anything interesting. No. Okay. Is there anything specific about hyperbolas there? Yeah.
Why did you use the plus or minus 3?
Where?
Yeah.
Well, like I said, we did the little box, and then I just had to draw through the corners. But the plus or minus 3x, up 3 over 1, up 3 over 1, that's the equation of that line. So that is the equation of the lines that are my asymptotes. So you could graph it directly from here, or you could graph it through the corners of the box. Personally, the box makes things easier, obviously. Then you don't have to mess with this and have to remember which way the ratio goes. No real need then. Okay. How about parabolas? Was that okay?
Yeah.
I mean, parabolas are old news, but the way that this looks at it now is a little bit new. So if I had that, then 4p equals, so in general, x squared equals 4py. And I've seen it written different ways, but this is the way that I actually was taught, so I like this way. And did I put them on here? Yeah. So p is kind of like it's got double duty. P is not only the focus location, but it's also the directrix location. So 4p here would be 8, so p would be 2. This is obviously my standard parabola, meaning that it's not opening like this or something. Okay, cool. So this tells me the focus is going to be at 0, 2. And there's nothing really to remember here. I know this is going to look like this somehow, right? And the focus has got to be in here somewhere. So there you go. If it was like this, if it was y squared equals 8x, it would open like this. The focus would have to be on the x-axis. So I would have put 2, 0. So I desperately want to make it so I don't have to memorize as much crap as it seems like I do. Yes?
I feel like I'm missing a little bit. The original formula, that's just standard formula.
Yes.
And then the second one is actually the formula.
Yeah, so this is an example.
Yeah, an example.
Cool.
How do you get from there to X?
So what the number here is 4p. Just like if I had y equals 7x plus 2, 7 would be the slope because it's in the right place. Cool. Same exact idea. Now, the idea of a parabola is you have this directrix. So here the directrix would be y equals -2. So on the other side. So you have a focus, in this case at 2. You have a directrix at y equals -2.
That is called parabolas already? Okay.
So the parabola is the set of all points that are equidistant from those. So 0 obviously is 2 away from both, the line and the point. The minute I want to start moving over, so then I've got to be, now this is going to be really fat, so then I've got to maybe be here so that this is equidistant from that as I move over, and then I've got to be maybe here so that this is equidistant as that. Those distances have to be the same so that I can build it that way. Maybe.
So the X just kind of like disappears and goes into wherever, and we just focus on the
Doesn't
number in front of the
disappear.
Y.
It doesn't disappear from this equation because it was x squared and y is to the first power. I know it's going to look like this, which helped me figure this out,
Okay, yeah, it was just for me, it was like, when is it going to be, because in the bottom, like in the y equals -2, so like, when do we went from x equals to y equals? I think I get it.
So the definition, again, the definition of a parabola is the set of all points that are equidistant from this focus and this line. That focus and this line are not part of the graph at all. They are actually what ends up constructing the graph. Just like a circle's center has nothing to do with the graph of a circle directly, except it helps set it up. I just go to all the points that are the same distance. Yeah. So these are the underlying structure. I like the way you put that. That's like the mesh, and then I mean the chicken wire, and then I put the actual thing somehow through it. My analogy completely. I obviously don't do arts and crafts, so excuse me. My paper mache.
I get it, so, from now on, like if we graph, like if you give us the equation for parabola, we have to put like the foci and the.
I'd have to be very specific because we do still have this. That is a valid format for a parabola, right? Where the vertex is HK. The A tells me if it opens up or down and how fat or skinny it's going to be, all that kind of stuff, right? This is just a possible alternate format that actually, if you'll notice, Chapter 11 is all about how do you construct these shapes. Circle, very simple. You start at a point and you just walk out the same distance to all possible degrees, and then you get the circle. That's the collection of all the points where you end up. So now we're trying to do the same thing with, well, what about parabola? You put a point somewhere and you put a line somewhere, and then it's all the places where the points are the same distance away. You end up with this parabola. So that's what we're trying to do. How do you geometrically define how to build these things? That's what this has to do with. Okay. In the grand scheme of things, it all depends on the application you're using as to whether you want to look at it like this or you want to look at it like this. Very often with lenses, for example, telescopes and things, you might want to, you're curious about where the focus is. I mean, there actually is a lot to do with that. So you would possibly want to look at it like this.
Are we going to see that on the test? Y equals A.
This one? No.
The block, okay.
You'll see, I'll ask you for this.
What about on the final exam?
On the final.
On the final, you'll see it both ways.
Could you explain a little bit more about that formula? Like, what is what?
This here? So the H and the K are transformations, right? So that's, the vertex would normally be at 0, 0. So this takes the vertex to HK. Move right H, move up K. This, if it's positive, it's up, negative, it's down. If it's 1, 1/8, it'll be very fat. If it's 8, it'll be very skinny. That kind of thing. That's all.
The bigger the number, the smaller.
So this could require you to put it, use completing the square to put it in the right format, right?
You said the bigger the number, the skinnier it is. Does it play into like the full pack thing moving in and out?
In a way, yeah, yeah. And here's a little more, I mean, if I move that closer, that would move the directors up closer, and that would change the way that the...
The parallel will look better, and the number will be smaller like in the other one, and if it goes bigger...
Yeah, so this 8 here is a little misleading because it's not in front of the x squared. If I divide it by 8, I get 1/8. That's why this thing would be so fat. Kind of with me? A little bit. Okay. Whew. All right. So I think if you remember, I cut 11.4 out of the curriculum, so that's part of the extra credit if you want to do that. So let me give you this. I want to. Oh, please tell me that I think. To be completely honest, I do have graphs of some of the parts that needed graphing for this, but I just didn't have enough time to slap that on the printer. So I might just scan it and send it to you guys later. So some of these say on graph paper, and you'll be like, all right, Chuck. But so I'll send it to you. Some of these say in class, so we need to do that now.
It's like my homework. Not a fan.
Make sure you have two sides. The printer and I hate each other in passion. So.
You guys have a lovely relationship.
It started in Yeah, we love to hate each other, exactly. So I think so just to make sure everybody understands, 5A and 5B, you're not going to see exactly that kind of problem in the test because those involve conic sections that have been shifted. Their centers are not at 0, 0. But I do have them on that graph paper that I'll scan and send to you so you can see how to set it up. But if I put something, let me just show you this. If I did give you an equation that was not in standard form, all right. So that is so not in standard form, but can somebody tell me, is that a parabola? Is that an ellipse? Is that a circle? Is that a hyperbola?
Oh, that's something.
The main thing to realize is the x squared and the y squared are different signs. So that would have to be a hyperbola. Right? To be a circle or an ellipse, they would have to be positive. They have to be the same sign, because at some point you can just divide the negatives away if they're both negative.
Why don't you just do one?
You kind of with me? So I could ask you that kind of question, just an identification question, if I really felt like it. Just want to warn you. But I wouldn't ask you to do it and then graph it, because that's beyond what the book has us do, so I'm not going to make you do that.
But, I mean, on the practice exam, you put something like that. Can you do it?
I know, if only I would have said something about that.
I know you did. I know you
Oh,
did.
okay.
But can you, like, work it out just so we can see it?
I did. If only I would have said something about that.
Where did you work it out? I don't see
Again,
it.
so I've worked part of it out on the answer key, and then I'm going to scan this bad boy and send it out to you because I didn't have time to print this.
Yeah, I was like, where's the women? I thought we were going to do it in the team.
All right.
Yeah, he loves that.
So is there anything else, anything you guys want to focus on now for, where's that word now? It's different meaning.
So how many sections? 8, 10.
Where's something that says in class? Number 9 says in class. Can't remember if I did that or not. Oh! Alright, let me show you this. I told you earlier, let's do number 9. And I want to show you a really nice shortcut. Because you know I'm going to make you, when I want you to graph a polar graph, you got to make the table. Oh, yeah.
Okay.
And you have
Yes.
the plank?
Yes.
Oh, you do?
Thank you.
So if you don't have a calculator, you want to play along, there's some here.
Is somebody taking fun?
What's that?
Because we're really registering. One into the
Stay. I think I just did this last time. All right, let's see. Whew.